Yeah, I think I'm gonna go have a check. Hey, can you check if I'm live? It says I'm live. I'm sure I think we're live. Give me one sec. Are we, Nitish? Yeah, I think we're live, Anshul. You can start.
We're live?
Yep, yep.
Nice.
Because I can
Hey
see.
guys, as Niharika would say, some of you have met me before. This is Anshul here. Always fun to be here with all of you for Camp K12 TV. Niharika, what episode would this be now for Camp K12?
One sec, it's 37th. I think.
37. Wow.
Yeah.
Welcome to Camp K12 TV episode 37 plus minus N. It will be somewhere around there. I haven't done this one in a while. I had last appeared for you guys a few months ago to do a 3D game development session. And we had taught you how to build a game, how to build a game where a character runs around collecting gifts. I think that was Christmas, right, Niharika?
Yeah,
Back
yeah,
in
yeah.
Christmas.
Yes.
Yeah, I was back in Christmas. So it's been some time for me. I came back on because I have a very special guest today. Camp K12 TV is making a tour around the world. Today we're making a pit stop in Canada. Next weekend in the United States, and we'll go from there. And today I have a supercoder joining us from the city of Toronto in Canada. It's his early morning. I'm actually joining you guys from California, and that's why I've gone with this background of the Golden Gate Bridge from my home city of San Francisco. And we are featuring coders from across the globe. So if you're joining us for the first time and you do not know what Camp K12 is, or you do not know what Camp K12 TV is, let me just tell you very briefly. We are a community of people who code and create, and we like to feature every single week a new supercoder across the globe. And today our supercoder joins us from Toronto, Canada. And we do this so that you all in the community, the coders as well as their families, their parents, have a chance to see what young people are creating across the globe and have a chance to build along with them. So Camp K12 TV is a weekly session where young kids teach other young kids to build awesome stuff. Today, I'd like to introduce my special guest. So Matthew, please turn on your video. And Grace.
Hello, everyone.
Hey, Matthew.
Hello. So, pretty good, you know.
Where are you?
What can I say? Canadian, yeah, in Canada right now. Right now, I'm in Toronto. This is the southern part of Ontario. Kind of close to gas.
You're wearing a t-shirt, so it's not that chilly.
Yeah, I mean, it's like 30 degrees.
Okay.
So
Not
it's
bad.
very hard to call it chilly.
Not bad. I think the people you're speaking with might be interpreting that as Celsius. He's talking Fahrenheit. What are you using?
Oh, first we're using Celsius.
Yeah, you're using Celsius.
We're using meters in Celsius. We're not, yeah.
Yeah. Cool.
We're kind of
So,
different from US.
You're in a very comfy place. I'm in Cali, and over here in Cali, it is slightly chilly in the morning. It was really nice outside just a few minutes back, so I've got my hoodie on. And I think a lot of people are also joining us from all over the world. So we've got people from India, we've got people from the Middle East, from Southeast Asia. And so different time zones, different metric system versus the American system. And so we'll try to talk in the metric system mostly today when we build 3D games, right, Matthew?
Of course.
Yeah.
Well, metric system, yeah, I suppose. It is the most widespread one, more or less.
Yep. I have to give you that. I spent a lot of my childhood in America, but I cannot deny the role that the metric system plays in the world today. So Matthew, tell us a little what's going on for you. What time is it?
Right now it's 10:58 a.m. It's, well, it's 11 a.m. I don't know. I did wake up a long time ago, so
Oh, you did?
hours ago. Yeah, so.
How many meals since the morning?
You know, I'm not a hobbit. I don't eat 2 breakfasts at a time. I'm a normal human being. I usually just, I haven't even eaten yet. Yeah, of course. So. Have you watched Lord of the Rings?
Yeah, I have, but it's been a while. Maybe my memory is not serving me well, do hobbits eat 2 breakfasts?
Yeah, they usually do.
And
like
2 dinners?
Yeah, no, well, not 2 dinners. I believe it's only 2 breakfasts. I think it was it's like a joke in the books.
All right. That's a joke that I had forgotten since I read those books. So you had 1 breakfast, and what did you eat for breakfast?
I didn't eat, as I said. I didn't eat, yeah.
You just didn't eat at all. I thought you were saying I'm not a hobbit as in I didn't eat 2 breakfasts, but you just didn't eat.
Yeah, I didn't eat at all.
All right. So you're joining us on an empty stomach, and
Usually works best for you to actually think like that.
Oh yeah.
Usually works the best.
You code better on an empty stomach.
Yeah.
All right, guys who are watching, if you also code better on an empty stomach, I'd love to see it in the chat later on when I see it. Right now, I can't see you guys chatting, but I'd love to go have a look later. I personally code better with a little bit of food. Doesn't have to be too much. It might be like a cup of coffee and just some oatmeal or something light. I definitely don't like to eat a pizza. And then, have you tried that?
You know what? I'm not just the type of person who eats fast food a lot. I eat pizza and stuff very rarely.
All right. Well, are you a type of person who codes?
Yes. What type of rhetorical?
The globe, and that's why you're here. So tell us a bit about your coding journey. Tell us a bit about what all languages have coded.
Well, my main language is Python. I do a lot of stuff in Python. I used to do a lot of stuff in Python. Right now, don't do much, but pretty much that is my main language. That is my main force, you could say. I could pretty much do, again, it probably would take me time to figure out a lot of stuff, but I could pretty much do anything. Build even advanced games if I wanted to. So my main language is Python, but I did have experience with a lot of others, like Java. I actually have a course on Udemy that I haven't finished right now. Then I kind of wanted to learn Java PowerShell, JavaScript, HTML, CSS, all of this kind of
quite
good stuff.
Broad spectrum.
Yeah, C#, C++. I did. There's actually a game, if anyone knows, if anyone, one of you knows Terraria. I didn't play it myself, but I just used to fun around. I used this tool called DNSpy, which is like a DLL unpackaging tool, and I used to actually just write like C++, just fun around with C++.
Very, very low-level coding, and I would be very impressed if anybody else watching this right now also codes in C and C++. Guys, if you do code in C and C++, give Matthew some love in the chat. We would love to see who does. Matthew, that's very impressive that you mentioned DLL, because it's been a very long time since anyone had to know what a DLL is. I think it's only if you're doing low-level programming or trying to build backdoors for games that you would.
Exactly.
Yeah, exactly. So we've got a pro coder here who is from the Python world, but today we'll be doing JavaScript, right, Matthew?
Yeah, of course. So
tell us a bit about what are we going to do today?
Now, today I wanted to kind of do, not super hard, not super easy, just an interesting facts to teach you how to do a grid. Basically, we're going to compare grid systems, and then we're going to do collision check. But we are not going to use the function collision check. We're actually going to write it out ourselves and look actually what is in there. How does it work exactly? Because you see, many people there's a function in HashXOR that immediately just checks collision for you, but it's not good if you don't understand what it does.
Yeah, I'll add on to what you're saying, because I think you're so right. When I started learning game programming, and I was teaching myself when I was in school, every library that you use. So today we'll be using HashXOR, which is a coding platform, a 3D coding platform that makes 3D, VR, AR really easy. It's a platform built by the Camp K12 team. But even if you were using something else like Unity, and in fact our guest for next week will be a Unity coder teaching how to make Unity games. Whatever you're using, there's a game system and a physics system built into the game engine and the coding platform. And so even back in the day when I used to code, there would always be functions that I could call that would do collision detection for me. I could just say, hey, is this intersecting with this? And I always wondered how it works. How do you detect when two things are moving in the world? If it's two balls, or maybe a ball and a wall, how do you detect that the ball is colliding with a wall? And in math class and physics class, you learn how to do this with in a very different way. In game systems, it's a lot more about the coordinate system and understanding the x position of something, the y position of something, and in 3 dimensions, the z position, the forward and back position as well. And today, Matthew is going to be showing us how, using HatchXR, we can understand what happens behind the scenes in a 3D game when we are animating 2 objects and they collide. How do you detect that those 2 objects are colliding or overlapping with each other? And we'll be skimming the surface of collision detection. It's a very deep topic, but with Matthew's help, we'll understand how it works and maybe talk about some of the more complex things that we didn't do today, that we don't do today. We'll actually give them a preview of and something challenging to think about. Because, when you and I were chatting about this, you had some fun ideas about how to detect specific points in 3D space and see if they're overlapping. But let's start a little. And guys, the way we have structured this Camp K12 TV session and the way we structure all our TV sessions is we will be coding with you and you can follow along. And I will be watching Matthew do this. I will be asking him some questions for clarification. So we'll spend about 30 minutes coding and watching Matthew code. After that, I would love to take a few audience questions from our coders from around the world that are watching this live and would love to share those questions with Matthew and see what he has to say about it. Matthew, does that work for you?
Hey guys.
Perfect. So then, I suppose no more talking, losing time. Guess we'll jump in.
Matthew, just 1 second. I'm extremely sorry. Anshul, we have comments which says that your audio is slightly lesser than Matthew's. Matthew's audio is way clearer. So can you try and increase your volume as well or check it on your end?
Very interesting. Very interesting. Niharika, are you observing that as well? Or
Yeah, even I'm observing it.
Okay. Is it multiple people that are not able to hear me?
I've gotten feedback from few people that so everyone's able to hear you. Anshul's, your just volume is slightly lesser than Matthew's. So if we can just.
Why don't I try to speak louder?
Yeah, that would help a lot. Yeah, this is better as well.
Because Matthew's speaking on a headset.
Yeah.
And I'm not speaking on a headset. I'm speaking into my.
Interesting. I can hear you pretty greatly, like right here. Maybe it's just.
Well, you're hearing me through Zoom. You're hearing me through Zoom.
All right. In any case, I suppose try to speak louder, and no more time to lose. We'll jump right in. So
before you start, Matthew, I just want to tell our audience that the link to the project template that we will be building on top of is included in the YouTube description text. You will see a bit.ly/ it'll say something about 3D game, and that's the link. It will open up a HatchXR workspace. So please click that if you would like to follow along with Matthew. All right, Matthew, over to you.
All right, so basically, can you hear me? Is my screen not glitchy, first of all?
Because it's wonderful. Yeah.
All right, perfect. So basically, what I want to do today, in order to show how it actually works, I basically built this kind of small project, just everything's kind of nice and stuff. But so to go over the logic that we're going to use today, I've got these 2 platforms, which is respectively named top wall and bottom wall. And in the end, I believe I can double click on this. And so in the end here, I actually have what I call the end of life, but it's very basically a wall that is going to be in the end, and we will actually be detecting collision in, before we get into these axes, I just wanted to show that we're going to be detecting collision from top wall, bottom wall, and this wall. So the logic would be here, ball would be bouncing from top to bottom, and once it hits this wall, its position will be reset to the position that is right here. So this will be kind of our logic and what we'll be trying to do.
Now, just to summarize, guys, those of you using HatchXR for the first time, it's a web-based 3D creation platform. When you open it up, you're on the Design tab, and on the left side, you see all the layers. There's a bottom wall, there's a top wall, there is you have a, what's the ball called? The ball is called ball.
Yeah, it's called, the ball is called.
End of life is also another ball. Okay, can you just show us what X, Y, and Z mean by selecting the ball?
Exactly. This is what I wanted to show. You see, HatchXR doesn't know when you tell him to go up. He doesn't know that. You have to tell him which direction you're going. Luckily for you, there are 3 directions, respectively up, which is Y. Well, it's not exactly up, it's just called Y, but can it would be easier perhaps for now to think of y as up, z as x is right or left, and z is to you or further, or I guess closer, further or closer. So, but basically, this is kind of a 3D environment, and this is why we have these coordinates. So if we want to move, well, let's say, the ball up, we will have to increase the y coordinate because the arrows point in the positive direction. If we want to lower the ball, we will have to negate the y direction. So we will actually have to make it lesser. And same thing with z or x, depending on which direction you want to go. If you want to go further, I guess further from that direction, you have to add it, and closer to that direction, you have to subtract. Now, let us actually go in the code.
That was a phenomenal of the axes, Matthew. Thank you for that. I'm going to add one more thing on top of it, which is that the arrows point in the direction of the positive direction. So when he told you what's up versus what's increased versus what's negating the position, that's it's because up is positive because the arrow is pointing up, and the side that doesn't have the arrow is the negative direction. Go for it. And that ocean looks really cool. That water that you have.
Yeah.
For those of you who have used Hatch before, this is a very special feature called an animated texture. And we will not disclose yet how we did it. Maybe at the end we can ask the audience who all knows how to do it. It's a special technique.
Right.
Go for it.
For, I guess, how we'll begin is, first of all, without taking the collision, we want to just get the ball moving. This is the basic stuff. This is how every coder begins, just with a simple line of code that does something. There, we can actually begin to build on. So, there are these wonderful functions there. If you see, there's scene-specific layers are basically objects in the scene, and the globals are basically special, I guess, functions and utilities that allow you to do something very useful. For example, there are timers. A timer, for example, is a very special function that allows you to do something. So, for example, the syntax is like here. Between let us say every second, because it is measured in milliseconds. So, what timer allows you to do?
For 1,000 equals 1 second. Yeah.
Every one specific amount of time that you set up in here, it will do or execute in programming language whatever is between these parentheses. Basically, that's what timer does. It's a function, and a function executes something, but it's a very special function because it executes something every some amount of time.
Nice.
Now, let us actually begin. So we actually kind of define what our timer is. We want to get the ball moving. To get the ball moving, we have to set up its speed. There are wonderful things called variables in Hatch.xr. Basically, variables allow you to name something and assign a value to it. And then so you wouldn't type every value in there, but you would actually kind of, to define it easily, you would actually use that variable and paste it whenever.
Have you used variables in any other programming language?
They're pretty much in every other programming language. Yeah. It's like Python.
It's actually not something specific to Hatch, and it's not something specific to 3D programming. Today we're using JavaScript, and in JavaScript you can initialize a variable and declare a variable using var. But there are other ways of declaring variables in other languages, and as you said, everything from C to C++, the low-level programming languages, as well as more modern ones, will all have a concept of variable. Matthew, can you tell us? Yeah, go for it.
Although I'm pretty sure the only other language I encountered that doesn't have variables is JSON, but it's used in the like AWS and cloud platforming. So that
notation JSON is a very specific structure, and I would not call JSON a programming language.
That is what I wanted to say.
It has a syntax, and it does not need variables because it's basically a way of structuring data.
As I said, it's used for cloud structuring. It simply doesn't need them. Yeah.
It's a great way to, so let me actually build on top of that. You're bringing up a really good point, and like the fact that you said cloud structuring, you're clearly very knowledgeable about how the web works, how the internet works. So guys, when you send data from application on your phone to the internet, you need a really clear format that both sides understand. Yeah, Matthew, you can keep coding while I'm talking through this. And choose an example of a format in which you can structure data, which both sides understand, the server as well as the client side. And it's not a programming language, so it doesn't need variables. That's what JSON is. And some other time we'll do a session and a Camp K12 TV session on how the internet works and how websites send data between one website and another website, or between the front end of the website and the back end of the website. Today, we will not be working with web servers. We're working on a 3D game that runs on your own system and doesn't need to talk to, or it doesn't need data from any other system or any cloud server. All right.
Right.
So what you've been doing over the last 30 seconds.
Right. So what I did basically here is I set up a variable. So in this variable, it's just a name. This name is an empty space. But to this empty space, I send an integer. Well, not really an integer, a float, but in any case, I send to the number 0.1. So what this does is, and then to move the ball up, because we're moving in the positive y coordinate, which is upwards, as already said. So what I'm doing is every 50. Well, I think this is every 20. I believe this is like every
20 times a second. 20 times a second.
20 times a second. Yeah.
1,000. Yep.
Yeah. So every 20 times a second, I'm increasing because I'm setting the ball's y to the current the position of the ball's y, plus adding to this people. So every 50, basically every, as you said, 20 times a second, I'm increasing the ball's position by 0.1.
Nice.
Now
Run it.
Let us actually check what this does. Hopefully I didn't get anything wrong, because see, it moves wonderfully. So this is exactly what it does. It sets the ball's position to the current position plus the seed ball every 20 times a second.
And it's gone way above our wall.
Yeah. But exactly. But for now, we actually, you can pat yourself on the back. You actually made the ball move. That is wonderful. For anyone out there who's using hatching, sorry to actually repeat the steps after me, but basically we got ourselves the ball to move. But we need the ball to stop once it hits this wall. There are these condition checkers, what I like to call them. If-else statements. If anyone heard of them, they're very common and pretty much everywhere. They're just used to check the truth of something or the falsity of something, and then execute the code within. So the syntaxes for if statements are if something within these parentheses, if it's false or true, doesn't matter. It has to just check for something, and if the condition, I guess it doesn't need to be false or true. If the condition is equal to what the if statement checked, it doesn't matter if it's false or true. Execute the code within these two parentheses, like right here. So just to clean it up, I'll indent this. So right here, okay, never mind. I think I did the wrong thing. So for now, we have to check whether the ball's y is actually. So here's the logic here. Since the wall, so think about it like this. If I go in the design and actually show you how to load it. So the wall's position, the wall's position has to be higher in the y than the ball's position, because it's moving in the positive direction. So here, so we have to check whether the ball's position is actually lower than the wall.
Try physically dragging the ball up and show them what happens to the y.
Oh, yeah. So look here. So right now the ball's y is 7. If we drag it, it will increase. So we actually see if it actually goes through the wall, it's constantly increasing. So we want the ball's y to be actually lower than that of wall.
Yep. Or in other words, the wall's y to be higher than that of the ball.
Yeah.
At all.
Doesn't really matter. I'll still set up with the ball, so not to confuse people. So how are we going to do this? Actually same function. It's actually severely easier than I just use all this terminology, but it's really. So what we're actually going to do is get y. This will return an integer value. So a number value, let us say, because we don't know whether it's an integer or.
These are all floating point numbers in the computer's memory with decimals, because you're moving them by 0.1 every time, right?
Exactly.
So it'll be 5.
Yeah. So bold and get y, we must set it to be lower than that of top wall y. So the top wall is this. So top wall is this object. So we have to set get y. And if it's lower, for as long as it's lower, the speed ball actually.
I think you wanted to know if the ball goes above the.
Yes, that is what I wanted to say. I think So if it's above, so for as long as it's okay. To explain this is for as long as it's lower, our speed of the ball will be constantly 0.1. But once it gets higher than the wall, we will actually set the speed ball to be 0. Constantly forgetting these things.
That's okay. More recently, JavaScript language has made that semicolon optional, and so most coding editors with it. But I think just when you're practicing JavaScript, it's best to keep that habit of semicolons. But go for it.
So let us actually now run the script. So if it's actually higher than that wall, we'll set it to 0. Nice. See, it stopped. Perfect. And since the actually, one thing I forgot to mention is the coordinates of objects in hashix are actually counted from the middle, which is actually kind of interesting. You see, it actually got stuck right in the middle. It didn't get upper or lower. It just got stuck right in the middle because the coordinates, the actual origin of x and y in hatch, are in the middle of an object. But it works actually perfect. Now, you see, because we want the ball to bounce, we'll actually set the speed to be negative because we want to reset it just so it could bounce off because we want to actually move it in a negative direction rather than positive. So what I'll do is the easiest way to do it is speedball. Basically, we're doing what? We're setting the new value of speedball to the old value of speedball multiplied by -1. Now, why -1? -1 is so if we actually take 0.1 multiplied by -1, it will be minus 0.1, which means the direction will now be negative. And if you remember, the negative direction means the ball will actually be getting lower. So let us then actually check this statement now. So it moves every time. See, it's perfect. It actually got bounced off.
It bounced off. Amazing.
Yeah, which is actually surprising.
And it went through the bottom wall.
Yeah, well, it went through the bottom wall, but I thought it's gonna get stuck like usual. like we did in those. So now.
Hey Matthew, you need just time, now that you've done it for the top wall, just do it very quickly for the bottom wall so that we have enough time to finish what you want to do, which is for it to reach the end of life as well.
Yeah. Basically, we're doing just the same thing. We'll actually copy it because coders are very lazy people. We like to copy everything. So right now, basically what we're doing is we want the ball to be higher than the wall, which means the ball's y has to be higher than that of the top wall. So basically, we're just going to reverse the statement. And again, we're just going to reverse it. So we're going to reverse the statement and again, keep the reversing. So what this does is, never mind. I used the top wall. Yeah. I forgot to change the value. The bottom wall. Excuse me for that mistake. I forgot constantly. See. So right now.
Awesome. You have a Earth bouncing between two walls. Oh, that's so cool. It dips in the water and then it comes back.
Yeah.
That's awesome.
Exactly.
So because streaming this over Zoom and then over YouTube, there's going to be a slight delay in the frames. But if you try this code on your end, it looks amazing. I've seen Matthew do this before, and it just looks phenomenal. And he'll share his finished code at the end, so you can see it running on your VR headset or on your phone. That's actually a good point, Matthew. What you're building is compatible not just with laptops, but also with tablets and with phones. And you're going to generate a QR code for them at the end to allow all of us to be able to run this in VR mode on our phones. I'm very excited for that. You've got a bouncing thing. Now, why don't you go ahead and do your end of life?
Of life, but shouldn't we just kind of quickly do it? So,
yeah, I know what you're going for. So, guys, what Matthew has in mind is, did you guys notice that when it bounces after the Earth has gone halfway through the wall, rather than when the edge hits the wall? And then same thing when it bounces from the bottom, it bounces when the Earth has gone halfway through the wall, and then. So Matthew wants to show you how to fix that. Matthew, I think, sure, I think you can do it, but I think we can just explain it a little faster.
Mm-hmm.
I think you can explain how to do that, because that's where the magic happens.
Yeah.
That's where you really go deep in understanding collision detection and coordinate systems.
Yeah, so right now, here's our sphere. We have to look at the radius. The radius basically is just a line that goes from, you see this kind of squarey, like rhombus. It's a line that goes from rhombus, let us say, to this box, right? So you see this box kind of thing. It goes from the coordinates, from the origin, which is this rhombus, to the end of x, which is this kind of line. So this is called the radius. Radius is used to draw this kind of sphere. So what we have to do is, since the coordinates are in the middle, we actually have to check for the radius too. And so if we're going to check for the top, we'll actually have to add the radius for it to actually bounce off on this tip of the ball, not the middle. And same thing with the bottom one. We have to subtract the radius, so it would actually bounce off of the tip and not the middle. Let us actually go in the code and fix it. Unfortunately, in HatchXR, there is no way to actually inquire it simply from the object, so we'll have to set it up. So I'll call it radius, and it will be equal to 1.25, which is the value that I just showed back before. It's 1.25. Now, as I already said, basically I'm just going to do a quick math. On top of the get y, okay, never. This one, I believe, the ball, we have to add to the ball. On top of getting to the ball, we'll actually have to add the radius of the sphere. So let me call that up. So this pretty much the same thing as I already mentioned. If we want to check with the top wall, we add it, and if we want to check with the bottom wall, we subtract it.
Awesome. So what same thing here? Rather than whether the center of the ball crosses the top wall, you're checking whether the point that is radius meters above the center, which is the top edge of the ball. You're checking that top edge collides with
See. Now it actually collides on the edge. It doesn't go. Okay. It go. Oh, never mind. I added it by accident.
Verbally, you said it that we would have to subtract it, but then you.
Yeah. I'm sorry. I'm kind of messy with my code. Yeah. So in this case, we have to actually subtract it. See, I made a mistake. If we would have added it, we would actually count the same edge of the ball. But
you caught your own mistake, and that, I think, is a sign of a fluent coder, someone who catches his or her own bugs, debugs them by just the logic, and that's phenomenal. That's something that we could all learn from you.
All right, awesome. So yeah, see, it actually goes. Now, we'll have to add one last check. Remember when we were doing the position of the ball to actually move it up or down? What we want to right now is actually move it to the right direction, so we'll actually reach the end of life, that one. So I'm going to set up another variable. I'm going to call it ball x placement, and I'm going to set it again to be 0.1, just as the speed of ball. Okay. But the speed of ball actually y, and this is actually going to be x. So we're going to do the same kind of idea. We're going to go for set x ball. Basically, you know what? I'm just going to copy the whole thing. Let me type it out again. Basically, it's going to be the same kind of logic, except we're actually going to to actually increase its position x, and but except adding a speed ball, we're actually going to add ball x, please. Again, we could have used speed ball as the same variable, but honestly, just like making new variables to much more understandable in the code.
Allows you to also change your vertical speed from your horizontal speed at any time.
Exactly.
Right? If you were making a game and you want your character to run faster than he jumps, then this is exactly how you would do it.
See, and now our ball actually moves right. So it doesn't actually move in y coordinates. It actually moves through x coordinates, reaching that right point.
Can you update your code and share the QR with us so we can all try it once before you even write the next thing? Just update it. Yeah. I would love for all of us to get a taste on our phones if we have it. Guys, take out your phones if you have your phones with you, your mom and dad's phone or your own phone.
Here it is.
Yeah, did you update the code?
Yeah, already updated.
So guys, I'm taking out my phone and I am scanning. All right. Hello. There it is. Loading. Oh, amazing. That looks so good, Matthew.
Yeah.
Very scenic. Guys, if you got it working on your phone, message in the live chat. We would love to hear. This is beautiful. And it's going towards end of life. You know what you should do is maybe make it move a little faster in the horizontal direction.
Yeah, no problem. I'll probably make it 0.5, right?
Sure, that'll be super fast. Okay, go ahead and add your last piece of logic, and then let's show them how to make the camera follow the earth, so that even on they can actually follow it. Yeah.
So here's the thing. We're going to go for our last thing. We're actually going to check it, not with the top wall, not with the bottom wall, but with the end of life. And it's going to be in the x coordinate. Now, basically we're going to do the same kind of logic as with the y coordinate, except, we're also going to do the radius, except we're actually going to use the get x command. Now, again, since if you actually look even right here, end of life is actually further in the x coordinate than is the ball. That is why we actually have to check for as long as the balls, for as long as the balls x coordinate is lower than that of end of life, and if it's bigger, then we'll reset the ball's position.
And you could actually take the radius into account here also, because you want the front end. You could say ball.x plus radius.
Yeah. Again, we're doing here plus because we're actually going in the positive direction. That is why we're adding it, not subtracting.
Awesome. This is really cool.
So again, the thing check.
Let's just recap for while you're typing this. I'll just recap, guys. When you do collision detection in any game system, typically you get a bunch of functions. Like even Hatch provides a detect collision with function. When you use those functions, all of this math happens inside the function, and you never have to know how it works. What Matthew has done for us is he has shown us what happens when you look under the hood. What is really going on at the level of coordinates, x, y, and z, taking into account the shape of the object. So he's actually taking into account the radius of the ball. If it were a cube, it wouldn't be a radius. Then you would have to check the depth, the width, the height. If it were some other shape, like a dodecahedron, then you would need a different mathematics to get the distance, the location of the point that you're actually checking. All right, go for it, Matt.
So, okay.
You did something very interesting while I was speaking. You created a new variable, and you called it the ball current. Tell us why you setting the ball current.
So what I did here was I set it specifically. So before we actually go into this loop, before we change any of the balls y or x, I wanted it to save. I wanted the balls x to save in a special variable that gets its x that is right here. That is before it actually moves anywhere. That is right here. And so so basically what I did in this logic was I created this variable. I stored its x coordinates in this variable. So once we actually hit the end of life, we're going to reset the ball's. Basically, we're going to set the ball's position to its position that is right here. Basically reset it. We're going to reset its position. So let me actually run the script and see what it does. Oh, wait, what? Why is it not?
If the ball dot radius or get x is less, so I'll tell you why. It's because ball dot radius or get x is always less than. I think you want to make it.
Oh, never mind. Never mind.
It's just constantly setting. What it's doing is it's moving the ball forward. And then,
never mind. I just typed the wrong character because it's gonna be bigger. It's gonna be bigger. You're gonna check now. Let's actually see once it moves towards the end of life, which is right here. This kind of wall.
Here we go.
There it is.
Ooh. And it's back. And it's
reset its position. Yeah. So we actually, if we want to kind of catch the moment, so here it moves there, and there it is. It resets its position. Constantly does that.
It works. Nice job, Matthew. You did this one solo, and it's a pretty awesome piece of code.
Let me just now add all of these.
They've been commenting it for all of you.
Yeah.
All right.
Okay,
why don't you show us that last feature of how do we make the camera follow the ball so that even if we look at it on our phones and we don't have the arrow keys through which we can move around, we actually trace the ball's motion.
Let me just comment everything here. Yeah. So I have a very good tendency to forget what my code is. So that is why I comment everything. All right. So pretty much here's our code. Yeah. Just checked for everything. Yeah. Let me now show you the last feature that is honestly just amazing. Again, we could probably code it ourselves, but it would be honestly just a very big thing to make camera actually follow the player. So what it does is, if you actually go to camera, there it is. So basically, what this thing does is,
I think you've selected light. I think you meant to select.
Of course it is select camera. So there is this thing called follow an object constant. So what it does is, it basically moves along with the position of the object. So right now, if we set it to follow, so basically it follows constantly with the position, for example, of any object right here. We can select the ball, because that's what we want. The strength basically is how fluidly it moves. So for example, if 0 point something is going to be very slow and kind of glitchy, 1 it's going to be perfectly on spot. So, and here's the distance. So the distance is, if we remember, the coordinate would be z, the distance right here. X would be the distance from the object in the x coordinate, and the distance in the y. We want only thing we want is distance in the z, because we want it to move fluidly and perfectly. That is why I usually like to set it to 10, which is always a nice variable. And pretty much all of these options you don't really need. Well, basically, it looks at the thingy. It follows its rotation. So rotations are here. It's how rotated are the objects. So left, right, whatever you want. And the invert look direction, that's basically just, I believe it's from the other side, right?
And we'll cover it some other time. We'll cover it some other time. Yeah. It's for different use cases.
Yeah. So if I actually hit the play, there it is.
Yeah. Oh, and now the camera is moving with the ball. Yeah. This was awesome. Guys, give Matthew a round of applause. This is amazing. It's been an absolute pleasure watching you do this, Matthew, on live TV, coding collision detection system with a pretty solid design as well. I have to say, what you coded up before, or what you created beforehand, was very, very creative of you to have a space scene with an Earth bouncing between these walls.
Yeah, and it resets its position.
Awesome. Let's actually update the project so that everyone has access to it.
And that is what I wanted to do.
Yeah, perfect.
And I'll share the QR code.
That's awesome. And I would ask my teammates to share that same link, the bit.ly link with the template. Just share that again, because now the template has been updated and now the template has code. So this way everyone can see either via the QR code or via the link.
Yeah, again, if anyone in the chat actually wants, you can just scan it.
Moving really fast, it's moving smooth. Yeah. Oh, nice. It works for me. And that ocean at the bottom looks really nice. Good. All right, I think it's time for audience questions, guys. So I would ask, let me actually hop over and look at.
Wait, so should I stop my screen sharing or continue?
No, you can keep your screen share going. All right.
Yeah, if anyone wants to scan it, of course.
Anybody who wants to scan, go ahead and scan. Now it's time for audience questions. So guys, on the live chat, I'm actually on YouTube looking at your questions. Please ask a question from Matthew about the code, about the project, about Matthew's life, whatever you want, okay? And I will see the question here and I will ask it to Matthew, right? And teammates, if I'm not looking at the live chat and you get a question, you should send it to me. Right, your questions here. Okay, cool. Meanwhile, Matthew, let me ask you a question. So, we have just made the ball move and collide, taking into account the radius of the ball. What if the walls were really thick? If the walls were really thick, how would we have made the collision detection happen such that it does not go to the center of the wall? And what would we have had to do? Yeah, actually, can you make that top wall really thick? Let's just demonstrate to our audience.
Yeah, no problem. So, what this basically does, there are three values. There is depth, which is basically you can think of it as the distance. So let me actually say this. So width is how long are points in the x-coordinate. So with this point, along with this point, you see that this is called the width. This is how long basically the box is, but you can't really say how long it is. You have to say how long in which coordinate. So how long is it in the x-coordinate? It's parallel. It is basically the.
So in this case, it's 100 meters.
Yeah. So it's the longevity. Is the longevity of so the value is the longevity parallel to the coordinate. So in this case, the width is the longevity parallel to the x. This is how this time. I'm pretty sure the height is parallel to y. Longevity, and I believe the height is what we need. So if I'll set it to 1, see, it gets thicker.
Yeah, set it to like 2.
Yes, let me just. I can say. Oh, damn, that's really sick.
That's good. No, 3 is good. I'll tell you why. Because the radius of the ball is 1.25, so then the ball is going to perfectly fit inside.
So if we actually run the code right now, what it's going to do is the ball is going to completely disappear in the wall. So let me show you. See, it completely disappears. It's kind of actually, I think you should just reset the camera.
Because you are taking the radius of the ball into account as well.
But it pretty much just it pretty much swallows half the ball. See, it swallows half the ball inside.
And so the reason it's doing that is because it assumes that the wall is in fact not where the bottom edge of the wall is, but at the center of where the wall is. Because as Matthew was telling you, in most game systems and 3D systems, you assume that the y equals 0 position is in fact the origin, is the center point of that wall. So you have a thickness of the wall around it, you have a center point, above it, below it, you have the bottom edge of the wall and the top edge of the wall. We are detecting collision between the middle of the wall rather than the bottom edge of the wall. So the logic to make this collision detection happen at the edge of the wall is in fact the same as what you did to make the collision detection happen at the top edge of the ball. So for the ball, you needed the radius. For the wall, you're going to need the wall height. And that, I think, Matthew, we should leave it as a challenge statement for our...
Sure. I wanted to show it, but...
I know you can do it. Matthew was going to create a variable here and show how to do it. We'll leave that as a challenge problem. So make the walls thick and see if you can get the ball bouncing from the bottom edge of the wall rather than the middle of the wall. And it'll be a very similar concept. You'll have to add or subtract something to the wall's y position before you check it in the HTML.
Yeah.
All right. So
are there any questions in the chat?
Any questions? All right. Someone is asking. Yes. Okay. Got it. Okay, so there's one great question, which is, can you explain how does collision detection happen for a human figure? We'll tackle that one together. And then someone's asking, how do I win the Oculus? Let me actually share how do you guys win the Oculus, okay? So let me paste
What is
that.
the Oculus?
Yeah, I'll explain it in a moment. Okay, so our teammates actually pasted a different link here. Let me just ask our teammates to paste the link. One moment.
Yeah, and we'll actually do it the collision for human figures. That'd be really interesting. So we'll actually replace.
All right. So let me talk about how to win the Oculus, and then we'll talk about the human. So guys, the way you win an Oculus is we have a monthly Oculus giveaway, and we have a Google form which my teammate will be sharing with you. We wanted to put it inside the description. We just haven't gotten around to it yet. So you're gonna see a Google form link appear right below the description where it says template code for the game we built today, where it says submit your 3D game for monthly Oculus giveaway contest. We put the wrong link there. We're gonna fix that link right now, and it'll be a Google form instead. What you have to do is every month we have a giveaway where we allow kids to upload a 3D game that they've built using the Hatch platform. And because Hatch is a VR and 3D creation platform, we love to celebrate our winners with an Oculus headset. So it's a Facebook Oculus Go. And to win that, you just, go ahead. No, I think you're submitting the wrong link, Camp K12. I will, again, it's the wrong link. Let me share the other one. 1 second. You're sharing the same bit.ly link. Nope, again, you're sharing the same link. Let me find it. Oculus link. All right. Here it is. Here it is. Here it is, guys. I've just posted the right link 3 times, 4 times, 5 times. So that's the link, and I would appreciate if my team can update that in the chat thread. All right. So that's the link to winning your Oculus headset. And Hatch Kids is allowed. Yes. All right. Let's go to the question on the human collisions, and then we're going to go to, hey, you can submit any project. This is any game that you create. You will be competing with kids across the globe. We do a monthly giveaway, and if you win, you will receive an email from us. In fact, we will email all people who participate in this, as well as we have students across the globe that are participating right now, and we'll share the winner with you at the end of every month. We just announced last month's winner sometime back, the winner from May, and we'll announce it for June at the end of June. All right, so human collisions. That's an interesting one. Matthew,
Anshul, I'm pretty sure you can just open up your own Hatch project and share your screen because it might confuse my screen. So let me just stop sharing.
Yeah, you can stop. Yeah. So Matthew, do you have any thoughts on how human collisions are detected?
Well, in 2D, how you do this is you would actually create the box around the human. Create a box around the image, box around the image, which is transparent, you can't see it, but because the shape is irregular, you can't really detect each part of it. I mean, you can pretty much mold a special thing in it, like mold, but it would be really painful to do honestly, and it actually requires a lot of work. So I know all of these games, I don't know, like top of my mind, like For Honor, if anyone heard, like that type of game, where you've got basically these 3D, that actually requires a lot of work because these are 3D meshes that have each of their own part. Each finger is their own part, and they actually create special molds for each one of the objects, and then the text for each one, and that is actually a lot of work. The easiest way would be just to create a box around it and check whether something hits that box. Again, it would not be perfect, but that is the easiest way, I believe.
That was a phenomenal answer. And I didn't expect you to have that much depth into this. So guys, what Matthew is describing is this concept that you can approximate a very complex irregular shape as a collection of simpler shapes.
Yeah.
So even if you think about a circle, and Matthew, you and I have discussed this before. A circle
is a collection of points.
Yeah, a circle on a computer screen is actually created by having many small line segments. So how do you actually draw a circle? on a computer screen? Well, you draw a bunch of lines. You draw a bunch of lines, and as you make those lines smaller and smaller and smaller, they start to look like a circle. So imagine a sphere. If you have a sphere, it can be approximated in many ways, right? Well, spheres are easy to detect collisions with because you have geometry and mathematics that we understand really well. It's a regular shape. You have a center and you have a radius, and you can check if a point is colliding with that sphere by just checking if that point appears inside that volume created with the center point and the radius. What if something is not a sphere? What Mathew told you is you can actually approximate a human body as a sphere for the head, as maybe multiple spheres for the arms. Have you guys seen the Michelin Man? The Michelin Man is like this tire company mascot created out of a bunch of spheres. Right?
Oh, yeah.
Mathew,
Yeah.
talking about it? Yeah. So it's very common. You'll see it all the time in advertisements in the US and in, I don't know if you see them in Toronto, but the Michelin Man,
I've seen it in I've seen it in the other countries.
created out of many spheres. So he's got a sphere for a hand, sphere, 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 sphere. The joints are represented as spheres. The arms can be represented as spheres in the case of Michelin Man, or you could represent them as a cylinder, or you could represent them as a cube. Imagine like the whole arm is like a cube slightly stretched, right? A rectangular prism. So you can actually create a human body out of simpler shapes, and you can detect collision on those simple shapes. Let me actually share a screen with how Hatch does it in a very, very hacky way. Let me share. Actually, this is something that we should do another time, and we've done it in Camp K12 TV in the past, so I won't open my screen right now. But guys, if you guys code on Hatch and you use the collision detection feature that comes with the player, so actually, can you share your screen, Mathew? Let's show them something. So go to the player in your code. I want to show them how to detect collisions around the surroundings. Okay, and this is something maybe even you haven't explored before, but we'll do it live together. So click on the player on the left side. On the player. There, yeah. On the right side, scroll down and choose collide with surfaces. Collide with surfaces. Go up. It was one of the three options. Yeah, collide with surfaces as a player.
There. Oh, that was.
There you go. Now, can you scroll down? And yeah, and do you notice? Keep going down. Keep going down. It says collision. You see that? Yeah. Now, debug wireframe. Check the box that says debug wireframe. Boom. Okay. All right. Now. Yeah. There you go. Now remove. Can you go down further? Scroll down further.
Yeah.
Remove the follow. Just delete the follow. Yeah. Say yes. Okay. Now play your code. Let's show people what's happening. So what Hatch does is, in order to make it really performant, since this is running in your web browser, what's going to happen, guys, is that you are now inside this box, okay? And when you run around, the way that we know in Hatch that you are colliding with the environment, can you run around? So use your arrow keys. Like run around and go through the valleys and the hills. Yeah, try colliding with the pyramid.
Yeah, didn't work.
You got stuck, right? You got stuck.
Yeah.
Now try falling down into one of those. Yeah, exactly. So guys, how are we detecting collision between the human that could be in this box and the outside world? Well, the easiest approximation of a human is to just draw a box or a sphere around the whole human. The entire human can be...
Well, the box, I think the box would be a better version because sphere has these kind of, on the sides, a lot of space. Which I think the box would be the better version.
Sphere has a property that it requires every point on the sphere to be equidistant from the center. So if a human is taller than they are wide, you would hope that a human is taller than they are wide and are taller than they are deep, right? And so if a human is taller than they are wide, then a sphere is not a good representation. There you would be better off using it.
And let me tell you, there are a lot of wide humans.
Yes, there are a lot of wide humans, and that's fine. But the point is, even if they are wider than they're tall, even if, no matter what shaped human you get, what are the chances that a sphere is the best fit for a human? I think you're better off using a box. Exactly. So when you are the player in Hatch, whether you have a robot there on Hatch Kids, you guys know what I'm talking about, or you have a car. Imagine a car. A car is longer than it is tall.
Oh, yeah. I can actually follow the ball right here.
You can follow the ball. You can jump on the water. Why? Because the box around you now is the collision rectangle. Is a collision.
It's kind of glitchy, not gonna lie. What's so glitchy? Huh. That's interesting. It kind of moves by things.
The ball is moving in a glitchy way because your timer interval is 50, right?
Yeah, 50.
Yeah, and if you make the timer interval smaller, move it from 50 to like 20, it'll take up.
Yeah, I'll probably do that.
Your system. It'll take up more resources on your system, but it'll be less glitchy, right? So when you guys animate 3D objects and you do collision detection, the finer your motion increments are, and the finer your timer intervals are, the more smooth your motion will be, but also the more RAM you're going to take up, the more computing resources you're going to take up.
CPU.
Yeah, exactly. So thank you for the question about the human body. Very interesting question. And obviously, games that you guys play like Fortnite, PUBG, Roblox, they do not approximate. They do not approximate.
I thought PUBG was dead a long while ago. Oh, interesting.
It is very much alive. Yeah.
You learn something every day, I suppose.
So the more advanced the game, the more granular the human body is represented at the mesh level, comprising much smaller shapes, with collision detection happening in different ways. But that's the high-level answer. So we've answered the question. We've answered the question around the Oculus headset. We have answered the question around the human body. Someone else was saying, I have a question, but they didn't say what their question is. Alicia, you were saying you have a question, but you didn't ask a question. All right. How do I create tessellation pattern for collision detection? Shivani, I don't know what that means. Can we create a tessellation pattern as okay. I think by tessellation, she means like something that's not a box or a sphere. I think she means it's not a box or a sphere. The short answer is yes. Physics systems do.
Oh, so she means something gone, right? Because like decagon, for example, is neither a box nor a sphere. It's closer to a sphere, but it's not a sphere. So she means some sort of a gon, right?
Yes.
Like an gon.
It's like a 3D gon. Yeah. Dodecahedron. Yeah. Anyways, short answer is, guys, as you move away from spheres and boxes, you get into much more computationally intensive mathematics and processing. So is it possible? Yes. But a lot of game systems will simply approximate surfaces as flat triangles. And so no matter what you're looking at, even if it's the ground of a 3D game with lots of hills and canyons, it can be represented as just triangles. And you can get surfaces of those triangles. There are other ways to detect collisions as well, using physics systems without using the kind of approach we use today, where you are doing vector mathematics. And
scalar, multiplication, all that kind of stuff. Nice.
Yeah.
That's actually what Unity uses, I believe. They have a function called vector 3D and vector 2D. That's what they use for actual movement.
Yeah, so even Hatch has a lot of vector math in order to do collision detection. And you'll notice when you go through the functions exposed for each of the layers. But today we did not go through that. I think Matthew, potentially we can have you on again in the future for a vector math tutorial in 3D games. Next week, guys, we do have a Unity 3D game tutorial. So we'll see if we can weave in some vector math for you. I think it'll be a very young 6th grade child. Matthew was in 9th grade, and he is a pro Python developer who today taught us collision detection with JavaScript on Hatch. Next week, we'll have someone from the US who is going to teach us Unity game development. And guys, get excited. I think the week after, we have a young child teaching us how to build our own cryptocurrency with Solidity for Ethereum. So we've got an action-packed calendar for you, but we might have Matthew back in the future to do a
cryptocurrency with Ethereum.
Yep.
Didn't cryptocurrency drop significantly in the last month?
Price will
there were like memes about what's the guy's name? Elon Musk, how he just said something in the
I think we're going beyond the scope of this discussion, so we should let the people who are watching the show feel free to head home and go do their things. I guess we're all at home, but do their things. Matthew, we should let you go as well. It's early for you and you haven't eaten. But I just want to thank you for joining us for Camp K12 TV, and it was a very enlightening session. I thought it's rare that we get a chance to look under the hood of how collision detection works and actually have an intellectual conversation like the one we're having now about how human body collision detection works and whether you can do it using shapes and using vectors. So thank you for allowing us to have that discussion with you. And from all our side, have a great day to everybody. Matthew and to the rest of our Camp K12 TV attendees from across the globe. Everybody take care and see you next week. Thank you, Matthew.
Goodbye.
Bye-bye. All right.